Hello, today we will be talking about factoring polynomials. This will be a two-part series as there's a lot to cover with this topic. As always, I like to start with the concept of what factoring polynomials is. So factoring polynomials means to express the answer as a product of an irreducible polynomial, or simply put, simplifying the expression. So think of factoring as the reverse of multiplying polynomials. If you need a refresher on how to multiply polynomials and the FOIL method, I will link a video in the description below. So when multiplying polynomials in its simplest form, you typically have a quantity multiplied by another quantity. So this quantity multiplied by another quantity. Then you can use the FOIL method to get this equation, which is AC plus AD plus BC plus BD. Well, factoring takes that equation right here that we just had and reduces it back to the original quantities of A plus B multiplied by C plus D. After we factor, we're going to be back to the original quantity multiplied by the quantity. So as I stated, you can think of factoring as reverse multiplication, which is division of the greatest common factor. So let's look at a really basic example so you're able to grasp the concept. So if we have the problem 2x plus 2 and we want to factor, well, we look for the greatest common factor, which we can see here is 2. So if that's the case, we want to bring the 2 out in front. So how we do that is we divide each of the items inside the quantity. We divide each of them by 2. This one is going to yield x, and this one is going to yield 1. So we know that we have 2, because we brought that outside, multiplied by the quantity x plus 1. And so that's the answer. So 2x plus 2 factors down to 2 times x plus 1. And you can check your work by multiplying this 2 into the quantity, which is going to yield 2x plus 2, which is the exact same answer that we have here. So now that you understand the basics, let's look at a problem where the answers require two quantities. Okay, looking at our first problem, we have 8x squared minus 53x minus 21. So unfortunately, there isn't one way or one method that will allow you to solve these problems. It's trial and error. But hopefully, with the tips I'm going to share with you, you'll be able to make some educated guesses that will save you some time. So typically on a problem where the highest degree is 2, it is safe to assume that the answer will be two quantities multiplied by each other. So we have two quantities. Again, think of reverse foiling so you know that your answer will consist of two quantities that are multiplied by each other. So when thinking about reverse foiling, we are looking at turning this equation back into its factors. Okay, so I generally go through these steps that I have listed here to help me solve the problem. Step 1 is factoring out the largest common factor. Step 2, identify the factors of your first and last term. Step 3, identify the signs in front of your second and last term. Step 4, choose the multiples that will give you the summation of your middle number. And step 5 is I check my work. Okay, so step 1. What I first like to do is see if there's any number that all terms have in common, and I like to factor them out. So in this problem, 8, 53, and 21, we do not have common factors. However, as an example, if we have 2x squared plus 2x plus 2, then we see that the highest common factor is the 2. Divide each of these terms by 2, so we can bring the 2 out in front, and that would leave us x squared plus x plus 1. And so I personally like to work with smaller numbers when performing factoring versus the larger numbers. So I always look at step 1 and factoring out the largest common factor. However, in this problem, we do not have that, and so we will go just to step 2. So with step 2, it says to identify the factors in your first and your last term. So if we look at 8, we know that the factors are 4, 2, 8, and 1. And if we look at the factors of our last term, which is 21, we have 7, 3, 21, and 1. Okay, so step number 3, we need to identify the signs in front of your second and last term. We see that our second term is a negative 53 and our last term is a negative 21. Now the last term in negative 21 tells us that our signs or our operations in our quantity is going to be a positive and a negative. And we know that because a negative multiplied by a positive will yield a negative. So that's why knowing the sign of your last term will help you identify the operations in the quantities. So we know that a plus is going to be there and we know that a minus is going to be there. Now we don't know if this is the correct order, but we do know that it's going to be a plus and a minus. And then looking at the minus 53, the sum of AD plus BC, so we know that the larger value needs to be towards that negative end to get that value of 53. So now we go to step 4. Choose the multiples that will give you the summation of your middle term. So we look and we see that we have different options here. Obviously, we know that we're going to get 8 if we choose 4 and 2, and we know that we're going to get 21 if we choose 7 and 3. But how do you know which factor is going to give you the correct number? So this is where the trial and error comes in, because again, AD plus BC need to equal this negative 53. So if we wanted to, we can try 4 and 2, and we can try 21 and 1, just to see if it works. Now, what I personally like to do, I know that the x's will need to be added into our final answer, but I personally like to focus on the coefficients first and then add in the x. As you do more problems, you'll be able to do multiple steps at the same time, in which you will be able to add the x's in, but for simplistic sake, for explaining this video, I'm going to take out the x and then add it back in later so we don't muddy up the waters. So if I look at this, we have 4 times 2, which is 8, which is going to give us that first term. We have the 1 and 21, which is going to give us 21. It's going to be that last term, which is great. Now we need to work on this middle term. So we first do 4 times 21, which is 84. And then we do the 1 times 2, which is 2. So no matter what, if we have 84 plus or minus 2, that's not going to give us 53. Therefore, we have to choose different numbers. So if we try 4, 2, 7, and 3, 4 times 2 is 8, that's okay. 4 times 3 is 12. 7 times 2 is 14. 14 plus or minus 12 is not going to give us 53. We know that that's also not a correct answer. Now, if we want to, we can switch these around and put the 7 here and the 3 here. 4 times 7 is going to give us 28, and then 3 times 2 is going to be a 6. Plus or minus 6 from 28, again, not going to get us 53, so we know that that's not going to work either. We can move into the 8 and the 1. So we have 8 and we have 1, so 7, 3. 8 times 7 is going to be 56, and we have 3 times 1, which is 3. If we have the plus or minus 3, we can see that we're going to get the 53. We know that this is the correct number. Let's just multiply this all out just to make sure. If we have 8 times 1, that's 8. That gives us our first term. We have 8 times 7, and that's a negative, so minus 56. We have the positive 3, and now we have the negative 21. This does give us the correct sign of minus 53. This gives us our last term of minus 21. We know that these are the correct quantities. Now we need to add the x back in. How to get x squared? It's going to be x times x, and that's going to be our x squared term, right? Now we're adding in the 3, and we are putting in the 7. Therefore, this should be your answer, and we'll go to step 5 to check our work. 8x times x is going to be 8x squared. 8x minus 7 is minus 56x, and we have plus 3x. and then minus 21, 8x squared minus 53x minus 21. And we see that we have this answer, which matches our original equation. Therefore, we know that this is our factor and is the correct answer. Okay, let's look at our next example. All right, looking at our next problem, we have 50x squared plus 45xy minus 18y squared. We look at step 1, which is factoring out the largest common factor. We're looking at 50, 45, and 18, and we know that they do not share a common factor, so therefore we can skip step 1 and go to step 2. Identify the factors of your first and your last term. 50, we have 25 and 2, we have 10 and 5, and we have 50 and 1, and then for 18, we have 6 and 3, we have 9 and 2, and then 18 and 1. Now we need to move to step 3, which is identify the signs in front of your second and your last term. So we see that we have a negative here on the 18, which tells us that a positive times a negative is going to yield a negative, and so therefore we know that these are our operations, and with the sign in front of the positive, we know that when we add A and D plus B and C, we need to stay in the positives to get that 45. We know that our signs are plus and minus. Now again, we don't know if those are the correct placements, but we do know a plus and minus. So now we go through the factors to see if we can get a summation. We have 25, we have 2, and let's do 6 and 3, 6 and 3. So 25 and 2 is going to give us 50, which is going to hit that number. 6 times 3 is going to give us 18, which is going to hit that number, which is great. Now we have 25 times 3, which is going to be 75, and then we have 6 times 2, which is going to be 12, and 75 plus or minus 12 is not going to give us 45. So what we can do is maybe switch the 6 and the 3 around, so we have the 3 here and the 6 here. However, we know that 25 times 6 is 150, which is well over 45, plus or minus the 6 is not going to give us 45, so we know that that's not correct either. Moving on to the next one, we have 10 and 5. So let's try that. So we put a 10 here and a 5 here, and let's try 6 and 3. If we put a 6 here and a 3 here, then 10 times 5, we have the 50. We have the 10 times 6, which is 60. 3 times 5, 15. And 3 times 6, which is 18. We do see that 60 minus 15 is going to give us 45, which is exactly what we want there. We do know that these are the correct numbers within our quantity. Now what we need to do is really do the problem in full. 10 times 5 is 50. 10 times negative 6 is negative 60. 3 times 5 is a positive 15. And then 3 times 6 is your negative 18. Get a minus 45. We know, again, this is not right, which tells us that these signs need to be switched. If that's the case, we are going to delete this sign, and we're going to delete this sign, and we are going to make a minus and a plus. Now what that does is that brings this to a 10 times 6, brings it to a positive 60, and a negative 3 times 5 brings us to a negative 15, that positive 45. We need to add the x's back in and the y's, right? So how do you get x squared? Well, we have to multiply an x by an x. And how do you get a y squared? You have to multiply a y by a y. Step 5 is to check your work. So we get 50x squared plus 60xy minus 15xy minus 18y squared. 50x squared plus 45xy minus 18y squared matches our original equation, which then tells us this is our correct answer. And just so it's more neatly written, we will write it again at 10x minus 3y multiplied by 5x plus 6y. All right, let's look at our last example. Okay, here's our final example. I want you to try this one out for yourself to see if you get the same answer as me. So go ahead and pause it, and then when you think you have it correct, start the video back up, and let's see if we have the same answer. Step 1, we're going to look to see if we have any common factors between any of these items, and the answer is no. Skip step 1 and move to step 2. Step 2, identify your factors of the first and the last term. So we have 7, 1, and 7, and that's it. We have 8, which is 2, 4, 8, 1. Step number 3, and it's identifying the sign in front of the middle and the last term. So we have that negative. Positive times a negative is going to yield a negative. When we're looking at our equation, we have the a plus b, c plus d. We have ac plus a d plus bc plus bd. We know, again, because that's a positive, the AD plus the BC need to be positive when adding together. So we just need to make sure that we're yielding towards that positive number versus that negative number. With 7, we only have 1 and 7 as our options. Now it could be 7 and 1, but let's try 1 and 7. Let's just see if that works. And then we have 2, 4, or 1 and 8. So again, the thought is we're trying to get 10. Let's see if we do 1 times 8 and then subtract 7, that's not going to work. However, if we do 1 times 4 and we do 7 times 2, that's going to work, because if we have 7 times 2, that's 14, plus or minus 4, then we're going to get that 10. And we already know, again, that we have that positive and that negative value. Let's just see if we, by inserting the positive and minus signs in this fashion, will yield us the correct sign. We have 1 times 7, which is 7, which gives us our first term. Then we have 1 times 4, which is a positive 4. We have negative 2 times 7, which is a minus 14. And then negative 2 times 8, which is that negative 8, which gives us our last sign. So this yields a negative 10. So therefore, we need to flip the signs around. And by flipping the signs around, that's going to give us the 1 plus 2, and then 7 minus 4. Now what we need to do is add in the x's, if you haven't already. So we do the x there, and we do the x there, and now we go to step 5, which is check our work. To rewrite this to make it look a little nicer, we have x plus 2, and then we have 7x minus 4. Now, when we have this, we do the FOIL method. With the FOIL method, we're going to get 7x squared minus 4x plus 14x minus 8, 7x squared plus 10x minus 8. This answer matches up here, and so therefore we know that this is the correct factor of this equation. How did you do? I hope you enjoyed this video. If you learned something, give it a thumbs up. If you have any questions, leave them below in the comments, and we'll see you next time.